Hey guys, so welcome to video number 4 for the 10 parts for 70 marks. So this one is a pretty big one. It's focusing on all inverse functions. The first thing I wanted to recap is some easy, medium, hard examples of just finding the inverse. So don't forget, there's 3 steps. We start by rearranging for x equals, then swap x and y around, and don't forget to rewrite y as the inverse notation once you have finished. So let's start with a nice easy one. Just following the steps, I'm going to rearrange for x. Okay, now swap my x and y's around and rewrite it in my inverse notation. Really easy. So next one gets a fair bit harder. It sort of jumps. When you've got 2 x's in the question, so most of the time that means it's going to be an exponential. Every single time you're going to have to, well, I shouldn't say, yes, I'm going to say every single time you're going to have to complete the square. So make a note of that on your sheet. Completing the square when there's 2 x's in the question in a quadratic. So remember, with completing the square, if you aren't confident with it, recap it because it is important. Bring your constant to the other side. And I use the plus box notation, which is then going to have y plus 3 plus box. So plussing box on either side. And remember, where box is equal to b on 2 all squared. So I'm just going to go ahead and clean this up a bit. Okay, so as you can see, my formula for the box is b on 2 all squared, where don't forget b is just that part in your quadratic. So subbing that in, I got a value of 1, put it on both sides in the box and clean it up, rearrange for x equals. So now I have done step 1. I swap my x and y around and then change my notation. So I'm going to end up with something that looks a little bit, and there we have it, my inverse. So again, just remember, when you have a quadratic, do completing the square. The last one, I don't think it's any harder than the medium one, but it just involves your logs and exponentials, so some people might find this one a little bit more complicated. Alright, so I'm just going to go ahead and put my solution up and then I'll talk through it with you. Okay, so let's have a look at what I have done so far. This step here, I just multiplied my denominator over to the other side. After that, I expanded the brackets here. Okay. Following that, I then brought my y e to the 2x to the other side here and my negative 1 over and gave me this line here. Now what I have is 2e to the 2x's, which I factorized out. And notice that factorizing step from here to here eliminated the 2 x's in the question. Now I just have one solo x in the question that I need to rearrange for. And finally, I am timesing by this bracket here, so I took that to the other side and divided. Now I'm left with just an exponential. I have to undo an exponential. And how do we undo an exponential? Yes, log both sides. So I'm going to go ahead and log both sides. And don't forget, logging both sides is going to cancel that exponential out. So once I logged both sides and I got the 2x, I divided by the 2, which I've skipped a few steps in this very last line here, but hopefully you can see in that one step I swapped my x's and y's back over. I changed my notation to my proper inverse notation here, and not only that, instead of dividing everything by 2, I just times it all by 1/2. Okay, let's keep moving forward. Alright, inverse graphs and their transformations. So remember, to draw the inverse of a line, you just flip it along the line y equals x. So all I've done is shown you an example of exactly that right here. So I have the line y equals x squared, the line y equals x, they intersect at 1, 1, okay? Oops, that's a positive one. And when I flip that over the line y equals x, it becomes this blue line here, okay? And how did I know it's y equals the square root? It's because if I take the inverse of that function by finding it, exactly what we just did, you'd find the square root of y equals x, swap my x and y around, and I get y equals the square root of x, okay? Which is my inverse function. So that's how it works. The other thing you can do And I find this can be confusing sometimes for people, but I learned it at uni and I've always used it just to double check things. If you're really struggling with finding what it's going to look like flipped over the line y equals x, this is my best way to explain it on here rather than showing you in person. If you take the page, whatever way the page is facing that you have to draw this inverse, if you turn it right 90 degrees, so hopefully with that letter F, you can see exactly how that's turned. Then take your left and right hand and flip them around so that you're flipping that F over, okay? If you do that and then look through the page, okay, obviously you're going to be looking at the other side of the piece of paper, but if you can see through the piece of paper whatever that function looks like, so it's going to be very opaque, you're only just going to be able to see this outline of the original, that is actually the graph of the inverse. So if I do get a chance, I will physically film myself doing this step and put it up in the link to it in this video. But hopefully you can see, you just turn it, rotate it 90 degrees, completely flip it upside down and look through it, and that is the inverse. It's a good way just to double check. If it's confusing you, don't do it. All right, and then we go into just knowing our trig inverses, okay? These are important. Now don't forget something. A graph isn't going to have an inverse if it fails the horizontal line test. What that means is if you draw a horizontal line anywhere on that graph, if it cuts that graph more than once, it doesn't have an inverse. It can have an inverse if we restrict its domain. So looking at the sine graph, and this is an important skill to be able to do, look at where you could restrict the domain. So cut it off so that when you did draw a horizontal line through it, it would only cross through it once. Hopefully you can see that if I cut it here and I cut it here and just have this part, that is going to satisfy the horizontal line test. All right, so now I've restricted that domain. I'm going to write the range and domain for that function, remembering sine goes up and down to 1 and -1. Okay, so I've done a few things here. I've restricted the domain for cos and tan where the horizontal line test passes. I've also drawn the line y equals x on each one, roughly. Now, all I'm going to do to draw the inverse is once again flip it along that line. One thing that's a feature of all inverses, when you take the inverse of a function, the domain and range actually flip around. So the domain and range, I've written here in red of my original sine graph with the restricted domain, they completely flip over to the opposite of each other. Okay, so my range becomes my domain and my domain becomes my range. Which means that when I flip it along this line, think about what that's going to look like. Okay, so if my range is at pi on 2, it's going to be up here. And then my domain is at 1 now. So now we've got to somehow draw this flipped over to look like that. So when I get that, I'm going to have, and hopefully you can see that's what I'm going to get. If you find that's a bit tough, you label your domain and range of what you know the inverse is going to be and sort of plot it out from there. Okay. Otherwise, I do know people who just memorize what that inverse looks like, but I do think it's an important skill to have an understanding how to get that graph of that inverse. Moving on though to something more commonly asked are now doing transformations. So not just graphing y equals sine. So I should note that that is the graph now of y equals sine minus 1 of x and y equals cos minus 1 of x, tan minus 1 of x, etc. So now they give us transformations. So obviously, you know, looking at, okay, well, what happens if I put a 2 out the front or a 2 in the brackets, etc. And it's knowing what that does. And these can come up a bit, and they are pretty tough questions. So expect them to be asked later on in the exam particularly. The first thing to note is that A and D, hopefully you know this already with just your general trig graphs, they affect the range, okay? Whereas B and C in there, those numbers affect the domain. So the idea is you want to put everything on the same side that affects the range and everything on the other side that affects the domain, in other words. So let's think about this. We have to draw 2 sine inverse of 2x. Straight away, I'm going to redo this with all of the range effectors put on this side and leave all my domain effectors on this side. So everything involving the range over there and domain over this side. And treat it like an equation. that's just going to give me the only thing I need to move on this question, gives me that. Now, set out, okay, well, what do I know on the normal inverse trig graph, which I had above here in yellow, my domain and range is going to be those, okay? So I write those out first. So I say, okay, my domain is between -1 and 1, and my range is between -pi on 2 and pi on 2. Now, what I'm going to do though this time is, instead of saying x in here, it's 2x, because that was what my domain affections were. And instead of y, it's y on 2. Now it's solving these two inequalities. So I'll put them over here. Dividing everything by 2 here gives me this. And then timesing everything by 2 here is going to give me just this. Now that is my new domain and range for this function. So let's have a look at the graph now. So if I just get rid of that for now. First thing I'm going to do is label my new domain and range, so I know where to go, how high and low. All right, so I have up to pi, down to -pi. I'm trying to put it as symmetrical as possible. Then I have out to a half, and pi on 2, sorry. And when you're doing this, think about, think about the scale of it to an extent, okay? So when we're looking at our -pi to pi in terms of then our, half to -1/2, pi is about 3. So half is going to be, quite significantly shorter. Despite that though, in the HSC, markers don't mind if your x-axis and y-axis aren't to scale of each other, as long as, say, your y-axis is to scale of itself. So you're not going to have pi here and -pi here and pi up here, for instance. Okay, now think about above here. This is the way that my sine inverse graph looks, kind of like a cubic, but definitely not a cubic. And it's going to have that action in here. Okay, one thing you can notice, see how it goes the same distance that way as that way, the same distance that way as that way. So what I can say is I know it's symmetrical about the origin because it's the same distance either side. So this is where I guess you could call it a point of inflection perhaps, but not really, that happens. So I know it comes up here because this is my y value and that's my x value, because that's what this is here. And then the same idea down here, and then how it looks, and there's my graph. Okay, all right, so if you want to pause the video, give the cos graph a go. It's the exact same process now, but now with cos. I don't know why that just moved. Okay, so you start with your domain and range, rearrange them, put them on the graph and join it together. Okay, so rearranging the equation, I get all my ranges on the left and my domains on the right. I get y on 2. And I've started with my original domain and range. Now I just fill things in. My domain is 3x minus 1 in here. And my range is y on 2. And then solve the inequalities. So I've labeled now my domain and ranges. And then it's just about knowing what does this look like as a inverse. And you should get something like that. Okay, so go ahead now and practice a whole heap more of those, get good at them and get confident at them. The last part of the video is looking at differentiating and integrating inverse. So start with your formulas, okay? These are the formulas you get for the derivatives. The derivative of sine inverse, cos inverse and tan inverse. Now, the way I do these can be slightly different to others, but I find it's much easier to pick up, in my opinion. It's kind of like a chain rule notation. So all I'm going to do is think about differentiating normal trig. I differentiate, well, this is the way I think about it. I differentiate what's in the brackets and times it out the front. So then I do that. Derivative of 2x gives me 2. and then I times it now by the derivative of this. I know by my formula the derivative of cos inverse gives me this over here. So I'm going to have -1 over the square root of 1 minus. Now instead of x squared, it's just going to be 2x squared there instead. So it's just about doing that technique every time, and they're not tough questions, okay? And that's what I get when I clean it up. So now let's think about tan. Exactly the same idea. I think, okay, differentiate the power, times it out the front. So dy dx. When I differentiate, sorry, not the power, the brackets, I'm going to get, well, that's really 3x to the minus 1. Derivative of that becomes -3x to the minus 2. So I'm going to put out the front that, just in a nicer format. Now I'm going to times by the derivative of tan inverse, and the derivative of tan inverse is 1 over 1 plus, and again, I'm not going to just put x, I put 3 on x, all squared. Okay, now I can clean that up a bit from now, because it isn't very nice to look at. And I get something like this. If I multiply that x squared in there, it actually cleans up very nicely for me. And there's my answer. So, differentiate the brackets, times it out the front, then throw in your formula. Easy. All right, integrating is possibly slightly more difficult concept, okay? Now, think about it in terms of a's, all right? So, instead of having just a 1, you've got a number there instead as well in your formula, okay? So, when we're doing this, I suggest to everyone to do substitution rules, okay? So, let's look at the first question here. My substitution, before I do anything, I'm going to write it in the form of a squared plus x squared, a squared minus x squared under here, just as the formulas are written. So, that's going to be square root of 3 squared minus 2x squared. So hopefully you can see why I've done that. Now that's in the form of something squared minus something squared, so it's looking like a cos inverse. Now I have that. Whatever, every single time, whatever is in here. Now, I'll put my substitution in red. Let u equal that. And make a substitution now, a u substitution. So, u substitution, du dx is 2. Rearrange for dx equals, and I get du on 2. Now, make my substitution into the equation. I get 1 over the square root of root 3 squared minus u squared du on 2. Now I can say once it's just a u in here, I can throw into my formula. I say, well, I know that's really a half now. I'm just going to take this out the front as a half. A half, and this is my cos formula, and cos is cos inverse of x on a, where a, remember, is just the number here. So cos inverse of x, remember, x in this case is going to be u, okay, because that's just whatever is being squared here, on a, which is root 3, plus c, and then return with my initial values, so replacing my u with my 2x. And there's my answer. One more. Let's have a look at this. Okay, so remember step 1. Let's rewrite it in the form we want. I get 1 over the, now there's no square root, so I have root 7 squared plus root 3x squared. Now it's in that form. Once again, whatever is in here, I let u equal. So I'll just put it down here. Remember, the x isn't part of the square root, so du dx is just going to be root 3. Rearrange, and I get du on root 3. So this is looking like tan because it has no square root on the bottom. And remember, tan is the only one that has the 1 on a out the front also. So now I say, okay, make my substitution. That's going to be the integral of 1 over root 7 squared plus u squared times b du on root 3. Take that 1 on root 3 out the front. Make sure you realize that root 3 is on the bottom, so it's 1 on root 3. And now I say, okay, I know that that is the tan, which is 1 on root 3 times by 1 on a, because that's the tan formula, of x. Now I'm just going to throw, I know that's u, but I also know that I'm just skipping a step here. That is just that on a. Okay, and clean it up. Okay, there is the end of my inverse functions video, okay? So please practice more of these, but it's a really good guide for a summary covering most of the topic.